So we're going to pick up where we left off last time, the power reducing formula. Oh, I forgot something. Okay, so if you remember, oh, actually we didn't do that part yet. So that proof only work out later. So your cosine of 2 theta is 2 times cosine squared theta minus 1. And cosine of 2 theta is 1 minus 2 times sine squared of theta. Okay, so really here, if we solve for cosine squared, okay, so if we add 1, plus cosine of 2 theta, and divide both sides by 2. And same thing here, if we solve for sine squared, that's 1 minus, I guess you can say cosine, subtract 1 from both sides, multiply by negative 1, 1 minus cosine 2 theta divided by 2 is sine squared theta. Now here, remember, if you subtract 1 from both sides, you would have cosine minus 1 divided by negative 2. Then if you multiply the numerator and denominator by negative 1, that becomes positive 2. Then the sine and the cosine, not sine and cosine, the 1 and the cosine switch signs. Okay, so remember, whenever you have cosine squared, that's going to be 1 plus cosine. When you have sine squared, it's going to be 1 minus cosine. Everything else is exactly the same. And if you have tangent squared, remember that's sine squared divided by cosine squared, which is equal to your sine squared is 1 minus cosine 2 theta over 2. Divided by cosine squared is just multiplied by the reciprocal. So that would be times 2 over 1 plus cosine of 2 theta. So your tangent squared theta, once those two cancel out, is 1 minus cosine of 2 theta. Clean up that theta a little bit. Divided by 1 plus cosine of 2 theta. Okay, so those are your power reducing formulas. All right, so let's say, for example, let's say if we wanted to rewrite 6 times, actually let me start off with one that's fewer steps here. Let's say instead of that, let's start off with a different example. Let's say 24 times sine squared of x. By using a power reducing formula. Okay, so we know just from the formula you just saw that sine squared of x is equal to 1 minus cosine 2x divided by 2. Or if you want it, you could just factor out that 2 and make it 1/2 times 1 minus cosine of 2x. Okay, so 24 times sine squared of x would just become 24 times 1/2 times 1 minus cosine of 2x. So all we did was replace our sine squared with 1 minus cosine 2x divided by 2. Okay, so we can go ahead and combine these two, because remember, everything here is just multiplied. This is multiplied by this is multiplied by that. So 24 times 2, well, divided by 2 is 12. So you have 12 times 1 minus cosine of 2x. So if you go ahead and distribute our 12, 12 minus 12 cosine of 2x. Okay. So we reduced it from a function with squared exponents to functions with just, I guess you could say, exponents of 1. So we really removed all the squared exponents, or the powers, hence the power reducing. All right, so any questions on that one? Okay, so usually when you have it squared, it's pretty straightforward, not too bad. It's when you get to the 4th power and 6th power that it kind of builds up a little bit. Okay, so let's do a quick example. Well, not really quick, but let's do an example of that one. All right, still writing. Okay, so let's say for our next example, if you wanted to rewrite say 12, forgot my 12, times cosine of 4, I'll say they use alpha. In the example, I'll use alpha. Using a power reducing formula. Okay, so here you want to notice that cosine to the 4th of alpha is equal to cosine squared of alpha squared. So it's no different than having x to the fourth being x squared squared. And cosine squared of alpha is equal to 1/2 times 1 plus cosine squared 2 theta. I actually left it as theta for a reason. Well, actually, I can change to alpha. Leave it a little less confusing. That may be a better way to explain it. Okay, so now that we notice this, we can get our cosine 4 of x. We can worry about the 12 later. But right now, let's get our cosine 4 of x, or 4 of alpha. Okay, so cosine 4 of alpha, remember, we already know that's cosine squared squared. Okay, so if our cosine squared is equal to that, then that's going to equal 1/2 times 1 plus cosine squared of 2 alpha squared. Yes.
Is it the formula? Isn't it be 1 plus cosine of 2 alpha instead of cosine squared?
Oh, thank you. Don't know why I put that there. Yep, so it should be cosine alpha. Cosine of 2 alpha. Nope. And don't need to mark it there. Okay. So here what we're going to do, we can distribute to have 1/2 squared, which is 1/4, times 1 plus cosine of 2 alpha squared. And we can really do that on the side. Okay, so 1 plus cosine of 2 alpha times 1 plus cosine of 2 alpha. We're just going to FOIL it out. Okay, so that gives us 1. Your outer is 1 cosine 2 alpha. Your inner is 1 cosine 2 alpha. So plus 2 cosine 2 alpha plus cosine squared of 2 alpha. Okay, so this becomes 1/4 times 1 plus 2 cosine of 2 alpha plus cosine squared of 2 alpha. Okay. Now we're okay because we've gone from a 4th power to squared. The thing is, we now have to reduce this one. And we'll do that kind of on the side. Okay, so here, let's say if we have, we'll let theta equal our 2 alpha. So that gives us cosine squared theta. So cosine squared theta, remember that's 1/2 times 1 plus cosine, let me move that over a little bit. Give that a little more room. Okay, so we know our cosine squared theta is 1/2 times 1 plus cosine of 2 theta. Okay, since our theta is equal to 2 alpha, that's going to equal 1/2 times 1 plus cosine of 2 times 2 alpha. So that's going to be 1/2 times 1 plus cosine of 4 alpha. Okay. So whenever you apply it more than once, that multiplies by 2. Okay. So when we applied it the first time, that alpha became 2 alpha. When we applied it a second time, that 2 alpha became 4 alpha. So if we applied it a third time, it would be from 4 alpha to 8 alpha. So it kind of multiplies by 2 each time. Okay, so you have 1/4 times 1 plus 2 cosine of 2 alpha plus our 1/2 again times 1 plus cosine of 4 alpha. And make sure I got it. There we go. So this just becomes that. Okay, so if we go ahead and distribute our 1/2 here, that's 1/4 times 1 plus 2 cosine of 2 alpha plus 1/2 plus 1/2 cosine of 4 alpha. Okay, so now we can kind of start simplifying things a little bit. Okay, so if we have our 1/2 and our 1, that's 3/2. So you have 3/2. 2 cosine, 2 theta, you can't really combine that with anything. You can combine them if they were the same, but by them being different, you can't combine those two. 2 cosine 2 alpha plus 1/2 cosine of 4 alpha. Okay. So now we can just go ahead and distribute our 1/4. Bring that up a little bit. Okay, so you have 3/8 plus you have 2/4, so you have 1/2 cosine 2 alpha plus 1/8 cosine 4 alpha. Okay, so remember, that's just our cosine 4 of alpha. Our original was multiplied by 12. Okay, so that's why I saved the 12 to the end, because if you had to remember to bring the 12 down over and over and over and over, it probably would have gotten lost somewhere. Okay, so 12 times cosine 4 of alpha is equal to 12 times 3/8 plus 1/2 cosine of 2 alpha plus 1/8 cosine of 4 alpha. Okay, so if we go ahead and distribute our 12, we end up with 12. You can reduce that to 4 times 3. Those two reduce, so you end up with 9/2 plus 12 divided by 2 is 6 cosine 2 alpha plus 12/8, which reduces to 3/2 cosine 4 alpha. Okay, so that would be your final answer. Uh-oh. All right, so any questions on that one? It's a little bit lengthy, and if you're not careful, there's plenty of room to make small mistakes. Okay, but for the most part, if you go step by step, you should be okay. All right. Okay, so let's the half angle identities. Okay, so your half angle identities. Sine of theta over 2 equals plus or minus the square root of 1 minus cosine of theta divided by 2. Cosine of theta over 2 equals plus or minus the square root of 1 plus cosine of theta divided by 2. Clean up that 2 a little. And tangent of theta divided by 2 actually has a couple. You could say 1 minus cosine of theta divided by sine of theta. It's also equal to sine of theta over 1 plus cosine of theta. All right. So the proofs, I'll add those with the scan notes if you would like to see those. All right, so let's say, for example, use the half angle formula to find tangent of 7 pi over 12. Okay, so let's say if we let theta over 2 equal 7 pi over 12. Okay, so if we multiply both sides by 2, it means our theta is equal to 7 pi over 12 times 2, or our theta is equal to 7 pi over 6. Okay, so that means our tangent of theta divided by 2 is equal to, we can actually use this one, sine of theta over 1 plus cosine of theta, which is sine of 7 pi over 6 over 1 plus cosine of 7 pi over 6. Okay. So sine of 7 pi over 6 is negative 1/2. And cosine of 7 pi over 6 is negative square root of 3 over 2. Move that up just a little bit. Okay, so that's going to be negative 1/2 over 1. Might as well say minus. Minus square root of 3, square root of 3 over 2. So if we wanted to, we can make that 1 equal 2 over 2. So you have negative 1/2 divided by 2 minus square root of 3 over 2. Okay. So instead of dividing them, we can rewrite it. Shorten that up a little bit. So that would equal 1/2, negative 1/2, times, to get the reciprocal of that, so you have 2 over 2 minus square root of 3. So you have negative 1 over 2 minus square root of 3, which if you multiplied it by the reciprocal, well, actually, you could probably leave it like that. Or if you want to rationalize the denominator, you can multiply both by the reciprocal. So let me do that just in case they ask for it. So negative 1 over 2 minus square root of 3 multiplied by 2 plus square root of 3 over 2 plus square root of 3. That's if they don't take that answer. Okay, which equals, if you FOIL your denominator, that will be first, which is 4. Your outer and inner cancels out. And I'll go ahead and write it plus 2 square root of 3 minus 2 square root of 3. And your last would be minus 3. Those two cancel out. 4 minus 3 is 1. So it would be negative 2 minus square root of 3. So either this or that one. All right, so any questions on that one? Okay, straighten up a little bit. Okay.